Now let's look more in depth at the Animations panel. To open the Animations panel, you can go to the bottom of the Designer Mode window and click on the Animations button. You can also press Ctrl-Shift Spacebar. There are two primary areas of the Animations panel. On the left, you will see a list of all current animations, a button to create new animations, and a search bar to find specific animations. On the right is where you will do the actual animating. Let's create a new animation. We can call it Animation Example. With the animation selected, we can now create animations on the right menu. The area in the middle here is used to add tracks that you want to animate. The far right area is your timeline, where all of your keyframes will go. Press the plus track button. You can see several options pop up in this menu. You can add tracks for the currently selected UI element at the top here. You can also choose from a menu of all currently available elements in the widget. You can add a folder for organizing your animation sequences. You can also add audio tracks, event tracks that will trigger an event at a specific time, and even material parameter collection tracks. Let's create a new button in the hierarchy. Click on this button and reopen the Animations tab. Click the plus track button and choose the button name at the top. You can see that the button has been added as a new track. Now we can choose which elements we want to animate. On the right of the button track, you see a plus button. If we scroll over it, it changes to a plus track button. This list shows all of the available tracks that can be added for animation for this button. Let's choose the background color track. You can see that now the background color track has been added under the button. If you expand it, you can see that you can animate each individual color as well as the alpha for this variable. To the right of this track, you can set keyframes, and you can go to the previous or next keyframe. Let's add a keyframe. Next, let's pull the time on the timeline to 2. This means 2 seconds. Add another keyframe. Go back over to the track and change the values of G and B to 0. You can see on the timeline that the color now shifts over 2 seconds from white to red. If you scroll across the timeline, you will see that the button changes color. Let's press play. Okay, we can see our button, but the animation doesn't happen. Why is that? Well, that's because it's not enough to just create an animation. We also have to tell the widget when to play the animation, and that's done in the graph editor. Let's go back to the widget and go to the graph editor. Now if we look in the variables section, we can see that an animations section has appeared. Open this section and we'll see our animation. Pull this variable to the event graph and get it. Pull off a wire from this variable and type play animation. Choose this node. Now hook up the execution pin to the event construct node. Compile the blueprint and press play again. Now we can see that the animation plays when the application starts. You can add a lot of dynamic elements to your UI elements in order to give them a very slick look. Experiment with the different effects you can achieve with the Animations panel. As you can see, the Designer Mode is a very powerful tool that will allow you to create virtually any UI that you want to create. It can also be fully extended with C++, although that is beyond the scope of this course. I will say that very rarely have I had to use C++, as the widget system is just so robust. With the Designer Mode covered, next we'll be discussing the Graph Editor mode. If you've created any blueprints in Unreal, then the Graph Editor mode window may look familiar to you. This is because it's very similar to the standard blueprint editor, and it works very much the same way too. There are several panels that you need to be aware of in the Graph Editor mode. The event graph is where you will program your UI. Any events such as on-click events and on-hover events will be programmed here. You can see that there are 2 unique events immediately available in a widget blueprint: an event pre-construct and an event construct. Event pre-construct works similar to a construction script. It will allow you to see the widget in Editor as it will appear upon creation in the game. Note that some functions will not work properly when using the pre-construct event. specifically anything that relies upon elements that only appear at runtime, such as the player pawn and character. Event construct works similar to begin play. It will execute as soon as the widget is created. It may also be called again when the widget is added or removed from a hierarchy. If you want to only call the event once at the start, use the onInitialized event instead. The blueprint panel contains all of your events, such as onClicked and onHovered events. Event dispatchers, which allows your widget to communicate to other blueprints and widgets outside of its immediate scope. Functions, which are little self-contained bits of reusable code. Macros, which are similar to functions but with some differences that we will discuss. And variables. The Details panel shows and allows you to manipulate all details for whichever item is selected in the Blueprint panel. You can set variable defaults and function inputs and outputs. You can also set up the class settings and class defaults for the widget by clicking on their respective buttons at the top menu. To see the compiler results panel, you may need to add it to the editor. Go to the main menu panel, select Window, and click Compiler Results. The Compiler Results tab shows all pertinent information about the widget once it has compiled. If there are any warnings or errors with the compilation, they will show up here. Alright, let's discuss some of the elements of the Blueprints panel. First off, functions. Functions are bits of code that can be reused. They can accept both inputs and contain outputs. To create a new function, go to the Blueprint panel and click the plus button next to Functions. Rename the function something that will make it easier to find later. Below in the Details panel, you can choose input and output variables. Within the function, you can also create what are called local variables. These variables will only be available within the function and cannot be accessed outside of the function. Now, functions can be very powerful because, similar to reusing user-created widgets, you can reuse the bits of code in multiple locations. This makes code easier to read and easier to maintain. Functions can also be called outside of their respective blueprint. So if I want to call a function in this widget from a separate actor in the world, I can do so. I just need to have access to that widget object and I can call the function from outside of it. Macros are similar to functions in many ways and also different in just a few. Each contains bits of code that can be reused. However, macros cannot be called outside of their respective blueprint. So another actor or widget cannot call a macro in this blueprint. But macros can contain latent functions. Now, a latent function is a function that will not be called immediately, such as a delay function and a move to function. Functions themselves cannot call other latent functions. Macros can also input wildcard variables, whereas functions cannot. A wildcard variable is an undefined variable type. The type will be defined at runtime. Macros are created in the same way as functions. In the Blueprints panel, click the plus button next to macros to create a new macro. Again, under the Details panel, you have access to input and output variables. A variable is a property that holds a value or a reference to an object or actor in the world. Variables allow you to track and manipulate these properties and references through blueprints. Variables can be virtually any object that exists in Unreal. They can be a number, a string of letters, a position, an actor, a widget, or any other object. Most UI elements that you add in designer mode can be variables. Some are automatically variables, such as a button, and some must be converted to be used as variables, such as a text. For instance, if we add a button in the designer mode and go back to the graph editor mode, we can see that the button is now an available variable. We can manipulate this button with blueprints. However, if we add a text block, it does not show up as a variable. To convert the text block to a variable, go back to the designer mode, and you'll see a tick box at the top right called is variable. If we tick this and go back to the graph editor mode, we see that the text block is now an available variable. We can also add new variables that will be used in blueprints, such as floats, strings, and actors. To add a new variable, click the plus button next to the variables section. In the details panel under variable type, we can change what type of variable we want to use. The small pull-down menu next to the variable type will allow you to convert the variable into a single variable, an array, a set, or a map. We can also set the default value of the variable if we compile the widget first. Binding is a way to connect a variable or function to a widget's property. For instance, let's say we want to bind a color variable to an image's color and opacity property. First, let's create a new variable and call it image color. Change the variable type to linear color. Next, let's compile the blueprint and switch back to designer mode. Drag a new image element to your canvas and click on it. You'll see that next to the color and opacity property, there's a drop-down menu called Bind. Let's click on this menu. Now we can see all the available variables that can be bound to this property. Choose the new image color variable. It's now bound to this color, so if we change the variable's color, then the color and opacity of the image element will update as well. Now if we click play in the editor, we can see that the image we created is the same red color as the variable. If we change the variable to blue and click play, we can see that it is blue. If you want to remove a binding, you can click on the same drop-down menu and click Remove Binding. Events are very important aspects of widgets. They allow you to connect logic to specific events, such as when you click the mouse, when you hover the mouse over an object, or when you change the value of a slider. Let's take a look at button events. Create a new button by dragging an instance to the canvas. Let's change the size to 250 by 50 just so we can easily click it. Now if we scroll all the way to the bottom of the details panel of the button, we can see that there are several events available for this element. On clicked, on pressed, on released, on hovered, and on unhovered. Let's talk about each of these. On clicked fires the event when you do a full click of the mouse, so a press and release. It fires on release. On pressed fires the event as soon as you click the mouse, before you've released it. On released fires the event only once you've released the mouse button. On hovered fires when your mouse cursor hovers over the button. And on unhovered fires when your mouse cursor stops hovering over the button. To use one of these events, all we have to do is click on the plus button next to it. It automatically takes us to the graph editor mode, centering on the newly created event. Now we can connect any blueprint logic we want to the button, and it will happen when we click the button. Let's connect a print string to the onClicked event. Compile and save and go back to the level. Click play and try the button out. When we click the button, it prints hello to the screen. Let's go back and test other events as well. Add each of the other events to the graph editor. Now we're going to add a print string to each one and change the text to what the event is called. So on pressed, on released, on hovered, on unhovered, and we'll also change the on clicked from hello as well. Okay, now let's see what happens. Go back to the editor and press play. Now you can see when I hover over the button it says on hovered. When I unhover, it says on unhovered. If I press the mouse button but don't release, it says on pressed. And when I release it, it says both on clicked and on released. There's several other types of events available, depending on the UI element. For instance, if we pull in a slider element and scroll down to the details panel, we can see there are different events. The most important would be the on value changed. This will fire whenever the value of a slider changes. So is where you would hook up logic to do whatever it is that you want that slider to do. If we pull in an editable text element, you can see that there is an on text changed, which will fire as soon as any of the text is changed, and an on text committed, which will only fire once you commit the text and press enter. Experiment with the various events you can use with each element. The event system is very powerful, and it allows you to connect virtually anything you want to buttons and inputs. Now let's talk about debugging. Inevitably, you're going to have issues that pop up with your widgets. As they get more complicated, it becomes harder and harder to track down where problems are. Knowing good debugging techniques is vital to help you find and fix issues. The widget reflector is a debugging tool that can provide helpful information to help debug your widgets. It can be used in editor or at runtime, so it's especially useful when you're deep in a menu during runtime and find a bug. There's a couple of ways to open the widget reflector. First off, you can open it right from your widget on the top bar. You can also access it from the main editor window by going to Tools, Debug, Widget Reflector. To use the widget reflector, you press the button on the top left here, Pick Hit Testable Widgets. You can see as soon as I click it, all of the widgets start populating the screen, even the editor UI. Now, if I hover over a button and press Escape, the widget picker stops changing, and I can use the mouse to find information about this particular widget. You can see the full tree that this widget is a part of. You can see its visibility, its focus, its clipping, and the details over on the right. It also tells you what widget this element is a part of, and if I click on this, it will take me to that widget. The widget reflector can help you debug issues such as why isn't anything happening when the button is clicked. If it's set to non-hit testable, or if there's something overlapping the object and getting in the way of the hit test, then you'll be able to see this information in the widget reflector. If you're trying to select a widget that is not hit testable, you'll see you can't select it in the widget reflector either. To choose this widget to find information, we need to change from Pick Hit Testable Widgets to Pick Painted Widgets. This will allow us to pick any widget that's visible on the screen. If your tree's getting too big and you're having trouble seeing the hierarchy, you can filter out certain elements. Specifically, if you choose UMG as root, it will filter out all of the editor UI and give much more space to your widget hierarchy. There's plenty of other options for debugging in the widget reflector, such as taking a snapshot of the hierarchy and various other views and windows, but that's outside of the scope of this course. Feel free to experiment and see what other information you can find here. The compiler results panel is another tool that you can use to debug your widgets. To open it, go to Window, Compiler Results. It also automatically opens if there's an error when you compile. If there's a compile error with your widget, the Compiler Results panel will give you information about the error. It'll also give you a link to where the error has occurred, so you can easily jump to the problem. Once you've resolved the problem, you can try compiling the widget again. As your widgets get more complex, it can become difficult to track down where a variable or function is being used. You can search your widget for any reference to the variable or function. To do so, find your variable or function in the blueprint panel, right-click on it, and choose Find References. Below, a Find Results panel will appear with all the references to your variable or function. You can then double-click on the reference and it will take you to that location in the event graph. This makes it much easier to track down where your variables and functions are being used. Now please note that if the variable or functions are being called outside of the widget, the Find References will not track this. It will only track the ones being used within the widget. Another useful tool with debugging is to use a print string node. This will allow you to track which execution path is being taken at runtime. Let's try it. On our widget, let's create a branch node from the onConstruct event. From there, pull off a wire from the true side of the branch and type print string. Change the text to true. Duplicate this node and change the text to false. Now hook up the execution pin to the false side of the branch. Go to the main editor window and press play. Now you can see that true pops up on the screen. So we know that the branch is taking the true path. We can also use a print string node to track a variable's current value. Let's create a new float variable and call it float test. Drag the variable into the event graph next to the event tick node. choose the Get Float Test option. Now drag the variable into the event graph again and choose the Set Float Test option. Hook the Set node to the Event Tick node. Next, pull off a wire from the Get node and type in a plus symbol. Choose the Add operator. Now connect the in-delta time output of the Event Tick node to the other side of the Add node. Then connect the output of the Add node to the input of the Set node. This will add the delta time to the variable every tick, so the variable will constantly be increasing. Next, pull off a wire from the Set node and type print string. Create the print string node. Press the down arrow and change the duration to 0. This way the screen won't get flooded by print strings. Finally, hook the set output to the print string input. You will see that it automatically converts the float variable to a string. Now if we go back to the main editor and press play, we can see the value of our variable changing over time. There's a couple of tools that you can use to change the structure of your widget hierarchy: the wrap with and the replace with. So if you right-click on your widget within your hierarchy, you'll see both options below. If you choose wrap with, you will be able to wrap the whole hierarchy from the selected widget down with another widget. In other words, adding another parent widget to the whole structure. You can see that if I use wrap with on this widget, I can wrap it with a number of options. If I choose Canvas, it adds a Canvas panel as the parent to this widget and all of the widgets that are under this widget. This can be very useful to quickly wrap a UI element, especially with more complex UI widgets. Replace with, on the other hand, will replace the current selected widget with a new widget type. If I right-click on the Canvas panel we just created, we can replace it with a number of different items. This will change the currently selected widget to this new type of widget. You really only have panel options to choose when using replace with, but it can be incredibly useful if you, say, have a canvas panel and decide later you'd rather it be a grid panel. Keep in mind that using wrap with and replace with tools might do some strange things to the look of your widget. The anchor, position, and size will most likely need to be changed for it to appear how you would expect it to. There's always a chance that your widget will break, but that's what the undo button is for. Two more tools that can be helpful, especially with complex hierarchies, are the Collapse All and Expand All buttons. Again, if we right-click on a widget in the hierarchy, we can see that these two options are at the bottom. Collapse All will collapse all children of a widget, while Expand All will expand all the children of a widget. This can really speed up workflow and increase visibility of your widgets. Clicking through every single child caret to open or close ends up being quite time-consuming, and you also have the danger of missing a widget. The caret button isn't particularly large after all. Use the Collapse and Expand All buttons to speed up workflow and help with visibility. There's plenty of panel types, and sometimes it's hard to figure out which one to use. Each panel is unique and has its own strengths and weaknesses. I like to use the canvas panels a lot because you get a lot of options and can tweak things to your liking, but it is one of the less dynamic panels, so it's not always the right choice. With a canvas panel, you can put the anchor in position anywhere you want. You have a great degree of control. The problem is that if I change the screen size and aspect ratio, it's very easy to lose part of the panel off screen. You have to keep this in mind when using the canvas panel and only use it in the right situations. I really like to use it for creating groups of widgets so that I can keep track of them, or if I know exactly what the final output screen size and aspect ratio are going to be. Another panel that works great, especially at a high level structure, is the grid panel. Because it uses percentage rather than absolute size, it will dynamically move if the screen size changes. This can make it a great initial layout panel. You can see that no matter what size I make the screen, the grid panel objects always stay on screen and scale with the screen. However, if I add text, you can see that there's still a problem with a different amount of text that is over the grid panel. That's something to keep in mind with a grid panel. If you have a number of buttons or images in a row, and you want them to dynamically change size and position, a vertical and a horizontal box can be incredibly useful. Vertical and horizontal boxes are static, however, and will fall off the screen if you add too many items to it. It's perfect if you have a set amount of UI elements that you want to fit in a certain area. If you don't know how many objects you'll need, say in a dynamically created menu, use a scroll box. This will allow you to scroll through all of the options available, and it will automatically work with however many items you fill it with. There's a ton of panels to play with. Don't get stuck just using one. Experiment and find the best ones for the best situation. If you're trying to create more dynamic menus for different screen sizes and shapes, move the screen size box around to see how the widget reacts to different sizes and aspect ratios. As I mentioned previously, there's several widgets that can only contain a single child widget. However, there is a trick if you want it to hold multiple widgets, and that's to use a panel. I'll drag a border element into the viewport, and then add a button to the border element. Now, what if I want to add a text element? You can see that the border element doesn't accept any more elements. I could add it to the button element, but what if I don't want to add it there? Or what if I want to add 3 elements? I can't do that. However, if I instead add a canvas panel to the border element, now I can add any number of other elements to the canvas panel. You don't only have to use a canvas panel, however, you can use any panel. If I wanted to, I could add a horizontal box to the border element, and then add images to the horizontal panel. If you want to move an anchor and keep the widget with it, you can control drag the widget. If you control drag your anchor point, it will keep the widget in the same relative position to the anchor point when you move it. You can move it anywhere you want and the widget will follow. UI can get really complex really quickly. It can become very difficult to find the widgets you want in the hierarchy. The search bar is very helpful, but only if you've named your elements something that you'll be able to search for. It's really hard to remember to search for text block 43. Make sure that you're renaming your widget something that you'll be able to easily search for later. It really helps to have a naming convention before you start creating your UI and then to stick to it. I usually name a widget something specific to the widget itself, and then the initials of the type of widget it is, or even the full name of the widget type for some. For instance, if I'm using a combo box, I might name it Options CB, or for a text block, I might name it Header Text. That way you can search for the specific widget, header text, or all text objects, just text, or all header objects, just header. Use whatever naming convention you want, but stick to it. Trust me, you'll thank me later. We talked some about user-created widgets. I would highly suggest using these where you can, especially where you're going to be duplicating similar elements. Think through how you can create a widget that will handle all the situations that you'll use this particular element for. For instance, are you using an inventory item? Will it always have a text name and an image? Make a user-created widget for it. Then expose variables that will allow you to change the text and image for each type of inventory item. This technique will save a lot of time in the long run, and it's how AAA games create their systems. The sooner you start implementing it into your own projects, the easier it will become to create advanced UI in your game or application. It makes life significantly easier. I know that it seems to go without saying, but have a plan before you start making a widget. If you have an idea in mind, plan out what you want to happen before you just start throwing a bunch of random widgets into the hierarchy. Think about how best to lay out the screen, what panels you'll need to use, and where you want the widgets to go. Does it need to be a dynamic menu? Is the menu going to change at runtime? Are there going to be multiple different screen sizes and aspect ratios that need to be taken into account? Is there a specific color scheme you're going to use? Also think through how you want the logic to work. What do you want a button to do? How does it need to communicate with other widgets? These questions are important to figure out before you start building your UI. It will save you so much pain in the long run with reworking or having to completely redo your widgets when they aren't reacting the way that you want them to. I like to use a software called Figma to lay things out before I get started. It allows you to move things around and lay things out really easily. And it's collaborative, so multiple users can affect the board at the same time. You can sign up for a free tier plan at figma.com if you want to try it out, but as you use it more, you'll need to upgrade to a monthly plan in order to increase the amount of boards you can have. There's plenty of other options too. You could even use Word or Excel if you want. It doesn't really matter what you use. What matters is that you plan things out before you start. Now that we've learned about the various elements that make up the widget system, let's put them to use. The project files that come with this project come with some various elements from the shooter example and the third-person template provided by Epic Games. They also come with a few free assets that you can use to create the elements for this course. Let's open the project. Once it's open, you'll see 4 folders in the content browser. The shooter folder contains all the data from the shooter example project. The survival game folder contains subfolders that will be used in our course, as well as some of the free elements that we'll use. The third person folder contains the third person template. And then finally, the Unreal Widgets folder contains a few examples for your reference. We're going to be working on the survival game folder, so let's open that. You can see several subfolders in here, such as blueprints, fonts, maps, and so on. If we open the maps folder, you can see that I've already created the 2 main maps that we're going to use for this project. M-Entry01 will serve as our starting map, which will hold our main menu and settings. M-Main-Level-01 is a stripped-down version of the main map of the shooter example project. It will serve as our main level where the game will be played. If we click on the blueprints folder, we'll see the main character that we'll be using. It's the third-person character from the third-person template. So we're going to be creating a simple survival game. But since our main character is a robot, we'll be replacing the normal survival elements like food, water, and health with battery, oil, and wrench. Our player will need to search through the level to find these elements to remain alive. A score will tick up with the time and will provide a final score at the end. We will be creating several widgets in this game, including a main menu, a settings menu, an on-screen HUD, and an in-game menu. Now we're going to need to create a couple of things for our survival game to work. So let's click on the blueprints folder and create a new blueprint. We're going to choose the actor type, and we're going to call this blueprint battery. Now let's make another blueprint and choose the actor type. We'll name this blueprint oil. Make another blueprint and choose actor type. Name this blueprint wrench. And then finally make one more and call it electricity. This one will hurt our character, requiring the player to find a wrench to fix themselves. Next we need to create our widgets, so let's go to the UI folder where we're going to create 6 widgets. The first will be called Survival Menu. The next, Slider Bar. Then End Game. The fourth widget is Start Menu. The fifth is Current Score. And then finally, Settings Menu. Okay, we're ready to create our survival game. Okay, so the first thing that we're going to do is work with our pawn. We're going to build everything into the third-person pawn. So in your content browser, go to Survival Game, Blueprints, and double-click on the BP third-person character to open it. Okay, go up to the Begin Play node, and then scooch it over just a bit. We're going to add a sequence node right after it. Now a sequence node is basically just going to perform all of the actions in order of the sequence pins. So let's connect the existing nodes to the second input of the sequence. You can do this by holding Control and moving the pin. We're going to use our pawn to add our widgets, but which widget is spawned will depend on which level that we're on. So let's pull off a wire from the sequence and type get current level name. That will get our current level so that we can use it to determine which one we're in. Now from there, pull off a wire from the execution pin and type branch. Our condition will be whether the current level is M-Entry01 or not. So let's pull out a wire from the get current level name and type equal exactly. In the bottom part of this node, type M-Entry01. Make sure you spell it right. Then connect the output to the condition of the branch. So if this is true, then we're in the entry level. If it's false, then we're not in the entry level. Now, let's right-click and get our player controller. Then pull off a wire and create a widget. Choose the Start Menu class, and then pull off a wire from that and promote it to a variable. That way we can keep track of it. Call it Start Menu and make it visible. That's what this little closed eye is. That will allow us to manipulate and get this variable from outside of this blueprint. Now, pull off a pin from that node and type add to viewport. Connect the execution pins to the true branch. So now, if we're in the entry level only, it will create the start menu widget and add it to the screen. Okay, so let's duplicate this whole section and then hook it up to the false branch. Once we've done that, let's change the widget class to survival menu. Delete the start menu variable and promote this new widget to a variable and call it survival menu. Once again, add it to the viewport, and now the survival menu will only show up when we're not in the entry level. Okay, next let's add two variables. The first we're going to name invert x, and we're going to make it a float variable. Once again, we'll tick visibility so that we can use it outside of this widget. The second variable we'll call invert y, and then once again make sure that it's a float variable and visible. Okay, let's compile this blueprint and then click on each one and set the default value to 1. Next, let's move down in the event graph to the camera input section, and we're going to scooch over the left, right, and the up, down nodes so we can make room for some other nodes. Now, each of these we want to multiply by these new variables. So let's pull in each variable and get them. Invert x is going to affect the left and right directions. So let's pull in a multiply node. Then we'll connect the action value x to the other side of the multiply, and connect the multiply to the add controller yaw input. So now it's going to multiply by the invert x variable. Now let's create another multiply for the invert y variable. Connect the action value y output to the other side of the multiply node, and then connect the output to the add controller pitch input. Okay, let's compile the blueprint and close it up because we're done with the pawn for now. Okay, so next we're going to work on the start level. So what we're going to do is go to the maps folder, and then we're going to open up the M entry 01 level. Now you'll see that this level is completely black. That's because there's nothing in it yet. So we need to add a couple of things to the scene. First off, let's add the character. So go to the blueprints folder and just drag the BP third person character into the world. Let's set the position Z to 90, X and Y to 0, and the rotation Z to 140. All right, next let's add a floor. So we're going to add a plane. Click the Add Content button, and then go to Shapes, Plane. Set the location to 0, 0, and 0, and then make the scale 10. Let's also change the material to metal, tiled, darker. Okay, we need to add a few lights so that we can see the scene. Let's do a nice 3-point lighting for this. Go to the Add Content button, Lights, Spotlight. This first one, let's set the Z position to 320 and X and Y to 0, and leave the rotation Y at -90. Also, let's scroll down and set the source radius to 20. Okay, now let's duplicate the light. You can actually hold Alt while moving the light, and it will duplicate it while it moves it. Or you can press Ctrl D if you're in Unreal 5, or Ctrl W if you're in Unreal 427 or earlier. Okay, the second one, let's set the location to -290, 220, and 12. Then let's set the rotation Y to 50 and the rotation Z to -60. Let's also lower the intensity. It's a little too bright, so let's put it at 6. Okay, that's 2 lights. Now let's duplicate this one more time for our third light. Let's set the location to 195, -270, and 12. Let's set the rotation Y to 40 and the rotation Z to 120. And then finally we'll set the intensity to 20. Great, now we have some nice 3-point lighting. Feel free to manipulate these lights however you want to. You can change the colors, you can change the intensity, whatever you think looks best. Okay, next let's make it a bit more moody. So I have a simple smoke system that I've built, and we can add it to the background of this shot just to give it a little bit more movement. So let's go to the Particles folder and then drag in the Smoke Niagara system into the scene. We can set its position to 141, 340, 0, and then set its Z rotation to -90. That looks good. Okay, finally let's add a camera. So we want to add a cinematic camera so that we have all of the post-process options built into it. So let's go to the Add Content button, Cinematic, Cine Camera Actor. We'll set the location to -588, 210, and 95, and then set the Z rotation to -10. Let's scroll down and then set the manual focus distance to 585. Then scroll down a little bit more to the lens area. Let's open it up and then open the exposure section. Let's tick the min EV100 and max EV100 and then set each of these to -3. This is going to constrain the exposure so that it will only stay at -3. Let's also search for constrain aspect ratio in the search bar. And then we'll untick this so that the camera doesn't show any of the black bars on the sides. Okay, the only other thing we need to do is to override the game mode. So click on the World Blueprints button and go down to the World Override, and then hover over the Game Mode Override. Go over to select Game Mode Base Class, and then choose the Game Mode Base class. Now what this is going to do is to override our third-person character with just the standard default game mode. That way this character isn't just going to be running around in the scene. It'll just be a standard stationary camera. Now we also need to possess the camera on begin play. So let's go to the level blueprint. First let's get our player controller. Then pull out a wire and type set view target with blend and connect the execution pin. This node is going to allow us to switch from the pawn camera to another camera in the scene, in this case our cinema camera. The new view target is going to be the camera in our scene. So let's drag this window out so that we can also see our main editor, then go to the outliner panel and grab our camera and drag it into our level blueprint. This will create a reference to our camera in the level. Connect it up to the new view target. Blend time and blend exp should be 0. Okay, now our camera will be possessed when the level starts. One more thing while we're in the level blueprint. Let's get the player controller and then set show mouse cursor. Check the tick box and connect the execution. This will show our mouse cursor when the level starts. Okay, done with the level blueprint. Okay, we have two menus that we're going to switch between in this scene, a start menu and a settings menu. So let's begin with a start menu. Go to Survival Game, UI, and then double click on the start menu. First, let's drop a canvas panel onto the hierarchy and rename it to root group. This will allow us to add other elements to this widget as necessary. Okay, next let's search for a grid panel and add one to our hierarchy under the canvas panel. Let's rename it to main GP and then change the anchor and position to fill all. So you can change both the anchor point and the position by shift plus control plus clicking the area where you want the anchor pin and position to go. Okay, next we can add 2 columns to the grid panel. And then let's make the size for each 0.5. Remember, 0.5 plus 0.5 equals 1. Make 1 row and then set it to 1. Great, now we can add a canvas panel and then we'll shift this to the second column. I'm going to call it menu group. Let's make sure that the alignment is set to fill in both the vertical and the horizontal direction. Okay, we can add a text block to the canvas and then rename it to header text. Set the anchor in position to center left. Then change the position Y to -300. Okay, I'm going to use the World Conflict font, which I included with this project, and then set the size to 90. Now we need to figure out what we want to name the game. I'm just going to call it Survival. but you can name it whatever you want. Okay, I'm going to add a line to go between the header text and the buttons. That way it'll break up the space a little bit. So I'll just add an image under the header text block and then rename it to line image. I'm going to set the anchor and position to center left just like the header. And I'll change the size to 650 by 2. Then I'm going to shift it up in position Y to -125. Now we're going to create the buttons. I want the buttons to just be text, so I'm going to use a little trick that I use quite often for this sort of thing. First, let's create a canvas panel and put it under the line image. We can rename it to New Game Group. Set the anchor in position to center left, just like the others, and then set the size to 150 by 50. And then we'll shift it up in position Y, -50. Now we want to create a text block and put it under the group we just created. Rename it to New Game Text. Set the anchor in position to center left and tick the size to content box. Let's change the text to New Game. I'm going to do it all in caps. We can make the font family Arial font and then change the font size to 18. Next, we'll grab a button element and drag it under the group we created. We'll rename it to New Game Button. Then we'll change the anchor point and position to fill all. Okay, we have a problem now because we can see that the button is covering the text, and we don't want that. We want to be able to see the text. We also still want to use the on-clicked and on-hovered events. We just don't want the button to be visible. So we want it to be hit testable, but not visible. So let's go down to the background color, and then we're just going to change the alpha to 0. That's going to make it invisible, but still hit testable. Great. Now let's duplicate this group twice, so we'll have 2 other buttons. We'll rename the first group Settings Group, and then change the text to Settings, again, all in caps. Make sure the position X and Y are set to 0. Also make sure to rename the text and button to Settings Text and Settings Button. Okay, rename the second duplicated group Quit Game Group, and then change the text to Quit Game. Set the position Y of the group to 50. And then again, make sure to rename the text and button also, so we can search for it easily later if we need to. Next, let's set up the on-hovered, on-unhovered, and on-clicked events for the New Game and Quit buttons. We'll do the Settings button later. So click on the New Game button, and then scroll down all the way to the bottom of the Details panel. Click the plus button next to the on-hovered event. This will take us to the graph editor, but we also want to add the on-unhovered and on-clicked events. So let's go back to the designer mode and do that. Click on the New Game button, scroll down, and add on-unhovered. Then go back again and add on-clicked. Okay, now we're ready to program these events. So for the on-clicked event, we want this to open the main level. So right-click in the graph and type Open Level. We're going to open the level by an object reference. So make sure you choose that one. Next, we're going to connect the execution pin, and then we're going to choose the M main level 01 asset. Okay, so now when we click on the button, we'll open the main level and start a new game. Next, we want to change the text color when it's hovered over. Since our actual button is invisible, we'll be changing the actual text block color instead. So let's create a new variable, and we'll name it New Game Text Color. Change the type to linear color, and then compile the widget. Let's scroll down to the Details panel, and we'll add a default value. So set the default color to white with a 1 alpha. Now let's go back to the designer window and click on the New Game Text element. Under Appearance, Color, and Opacity, let's bind it to this new variable. Let's head back to the graph editor. So we want to pull over that variable and set it. Then we're going to duplicate it, and we're going to connect one of them to the on-hovered and the other one to the on-unhovered. We'll change the hovered to a nice blue color. Now here's a nice trick. If we want to reuse this color for the other buttons, but we don't want to try to remember all these RGB values, we can actually drag the color right over here to the top above the color wheel. That's going to save the color for later use. Okay, now we can click OK. Next we'll set our unhovered color, and we'll just set that to solid white. Okay, let's compile our widget, and then we can test it out to make sure it's working properly. We can see if we hover over the button, it changes color. And then when we unhover, it changes back. Let's click on it. Okay, great. It takes us to the main level. Perfect. Next, let's hook up our Quit Game button. Go back to the Start menu widget. Again, we want to click on the button and add in the onClicked, the onUnhovered, and the onHovered events. This time for the Quit Game button. Once that's done, add a new variable and then call it Quit Game Text Color. Make sure its type is linear color, compile the widget, and then change the default value to white. Now we can set this variable in the same way that we did for the previous. Let's duplicate it and hook up both execution pins. Change the onHovered color, and we can see that now we can easily choose our previously saved blue color. Let's choose that. Then let's go down and change the onUnhovered to solid white. Go back to the designer mode now and bind it to the Quit Game Text Color and Opacity. Make sure to use the correct variable. Go back to the graph editor. Now for the onClicked event, we want to right click and type Quit Game. Connect the execution pin, and we're done with the Quit Game button. Let's compile it and just double check that it's working. Okay, we can see that the Quit Game button changes color now. And then if we click it, we quit the game. Great, we're done with the Start menu for now. Next, let's work on the Settings menu. Okay, now we're going to work with the Settings menu. So let's double click on it and open it up. So let's make this similar to the Start menu widget. Let's search for a grid panel and drag it into the hierarchy. We'll rename it to Main GP. Once again, add 2 columns and set them each to 0.5. And then add 1 row and set it to 1. Next, let's add a canvas panel and keep it on the left side. And we'll rename it to Settings Group. Add a text block under the canvas panel and change its name to Header Text. Set the anchor and position this time to right and center, and then change the position Y to -250. And then we'll change the text name to Settings, all caps again. So this one's going to mimic the other menu, so let's change the font family to World Conflict, and then set the font size to 90. Finally, tick the Set to Content box. Next, let's add a vertical box under the main canvas panel, and we'll call it Settings VB. Set the anchor and position to Center Fill. Set the position Y to 100, and the offset left to 50, and then the size Y to 480. Now let's add a canvas panel for each of our buttons. Drag a canvas panel under the vertical box. Pull down the padding and add a 5 to top and bottom. This will give it a little bit of space to work with between the buttons. Set the size to fill. Drag an image under this canvas panel, and then set the anchor and position to fill all. Change the alpha of the color and opacity to 0.2. Then drag a horizontal box under the canvas panel. Set the anchor and position to fill all. Lastly, let's add a text block to the horizontal box. Set the size to auto. Pull down the menu for the padding and add 10 to the left to give it a little space. Set the horizontal alignment to left and the vertical alignment to center. Next, let's go down to the font section, and we'll change the font family to Arial font and the size to 18. Okay, we're going to use this same basic layout for all of our buttons. So we're going to duplicate this canvas panel 7 times. So there should be a total of 8 canvas panels under the vertical box. Name each one of these as follows: character name group, difficulty group, invert Y group, invert X group, screen size group, gamma group, bloom group, and quality group. Let's also make sure to rename the background images and horizontal boxes their respective names. Just call them the same thing as the group, but for the image use _BG instead of group, and for the horizontal box use _HB instead of group. For the text use _text instead of group. Okay, when you're finished, it should look like this. Okay, now we're going to add some settings options. Let's start with a character name group. This will be an option where the player can change their name. Change the text in the text block to character name. I'm going to put it all in caps. Now let's add a text box element to the horizontal box and rename it to character name ET. We'll change the size to fill and press the little caret to see the padding options. We'll change the left padding to 10, and this will give it a little breathing room from the text. Let's give it a default value of player, and the hint text can be enter player name. That'll tell the player what to do. Under text style font, we'll change the font family to Arial font and change the size to 18. We also want to untick inherit from the color section and change the color to our blue color so that it's easier to see. Finally, go down to the background color and set the alpha to 0.2. Great, now let's make our difficulty settings. This will be the difficulty group. So first let's change the text for the text block to difficulty. Search for a canvas panel and drag one onto the difficulty horizontal box. We'll rename it to difficulty CB group. Set the size to fill, and then the top, right, and bottom padding should be set to 5. The horizontal alignment we can set to right. Next, grab a combo box and drag one onto the canvas panel. Rename it to difficulty CB. Set the anchor in position to right and fill top to bottom. Set the X size to 390. We'll add 3 default options and name them easy, hard, and impossible. Change the selected option to hard. This will be the default option when the player starts. Scroll down and change the down arrow padding to 5. Let's set up the font. Scroll down to the font and we'll choose Arial font and change the size to 18. I also want to change the colors to the blue that we've been using. So change text color, selected text color, and foreground color to blue. Let's tackle the invert X and invert Y. Change the text block for each to invert Y and invert X respectively. Search for a checkbox and drag one under the invert Y horizontal box and rename it to invert Y CB. Set the size to fill and the horizontal alignment to right. Drop down the padding and set the right to 2. Open up the style section and change the unchecked image size to 30 by 30. Now go down the line and change each of the next sections image size to 30 by 30 as well. Okay, now we can copy this checkbox and paste it under the horizontal box for invert X. We can rename it to invert X CB. Next, we're going to create the screen size dropdown. we can actually just reuse the difficulty dropdown and tweak it a little. So let's grab that dropdown and copy it, and then paste it under the horizontal box for the screen size. We'll rename it to Screen Size CB. Now we'll change the default options to 1280 by 720, 1920 by 1080, and 3840 by 2160. We'll set the selected option to 1920 by 1080. Next is gamma, and we're going to use a slider for this. First off though, let's grab a canvas panel that we can use as a group and drop it under the horizontal box. We can rename it to Gamma Slider Group, and then set the size to fill and horizontal alignment to right. Now grab a slider and drop it onto the canvas panel and rename it to Gamma Slider. Set the anchor in position to center right and set the size to 400 by 30. Scroll down and set the value to 0.5. Change the slider bar color alpha to 0.4. Change the slider handle color to our blue color. Scroll down and change the bar thickness to 20. Then scroll up a bit and change the normal thumb image, the hovered thumb image, and the disabled thumb image size to 10 by 20. Great, done with that one. Now let's do the bloom. We're going to do a checkbox for this, so we can just grab either the invert X or the invert Y checkbox, and we can copy that one and then paste it under the bloom horizontal box. Let's rename it to Bloom CB. We want this setting to start as checked, so let's go to the checked state and change the option to checked. Alright, the last section is quality. Again, we're going to use a drop-down menu, so grab the difficulty CB group canvas panel and copy and paste it under the quality horizontal box. We'll rename this canvas group to Quality CB Group and the drop-down to Quality CB. Now this one's going to have 4 options, so let's add an extra default option to the group. We'll call them Low, Medium, High, and Epic. And then we'll set the selected option to Epic. Great, now we have all the UI elements set up. And I realized that we forgot to change the text on the last 4 settings, so let's do that. This one should be screen size. The next one is gamma, then bloom, and finally quality. Okay, so now we need to program the logic for our settings menu. We also want to save the settings so that it remembers what options we choose. So we're going to create a save game and a game instance class. Go to the content browser and go to the blueprints folder. Right-click and create a new blueprint. Drop down to the All Classes area and type Save Game. Let's select this one and then click Select. So I'm just going to call it Survival Save Game. This blueprint is what we'll save so that every time we open the game, it will read our previous settings and apply them on start. Okay, let's create one more blueprint, and we're going to search for a class called Game Instance. I'll just name it Survival Game Instance. So a game instance is a special blueprint that will maintain variables between levels. Both the save game and the game instance are going to have the same variables in them. The game instance is also going to have a link to the save game file itself. Now let's start with the save game blueprint. Let's double click on it and open it up. You can see it looks very similar to a regular blueprint, but this one is only going to contain variables. We're going to add a bunch of them to keep track of. There's going to be a variable for every one of our settings and then one more for our high score. Alright, first let's create a string and we'll call it character name. Next we'll create another string and we'll call it difficulty. Then we'll create 2 booleans and we'll call them invert X and invert Y. Create another string and call it screen size. Create a float and call it gamma. create another Boolean, and we'll call it bloom. We'll create one more string and call it quality. And then the last variable will create a float, and we'll call it high score. We're going to use that one a little bit later. Compile the blueprint. Okay, now we need to set all the default values of this. That way, if it fails to load, it will still have variables that work with the game correctly. So I'm going to set the character name to player. I'm going to set the difficulty to hard. The invert X and Y, we're just going to leave it false. And then the screen size, we're going to set to 1920 by 1080. We're going to set the gamma to 0.5. The bloom we're going to set to true. We'll put the quality as epic. And then we'll just leave the high score at 0. Okay, let's compile it one more time. And that's it for the save game blueprint. Now we're going to do the exact same thing for the game instance blueprint. So let's open that up and then create all the same variables as the save game blueprint. Okay, once we're done with that, we actually want one more variable to track, and that's the survival save game variable. This is actually going to keep track of our save game itself. So create one more variable and call it survival save game, and then change the type to survival save game. As with the save game blueprint, we want to set the default values of the game instance. So compile, and then set the character name to player, difficulty to hard, invert X and Y, we leave it false, screen size to 1920 by 1080, gamma to 0.5, the bloom to true, quality is epic, leave the high score at 0, and then leave the survival save game alone. All right, let's compile it once more. Now we have to set the game instance in the project settings. So go back to the editor and go to Edit, Project Settings. In the top here, search for Game Instance. Okay, on the drop down for the Game Instance class, let's choose our new Survival Game Instance class. Okay, now we can add the logic to the settings menu, so let's open it back up again. Okay, now we can add the logic to the settings menu, so let's open it back up again. First, we want to create a new save game and set it as the variable for the game instance. Next to the event construct node, right-click and type create save game object. Set the save game class to our new survival save game class and connect the execution pin. Now right-click and type get game instance. Pull a wire from this node and type cast survival game instance. The cast node is going to allow us to not just get any generic game instance, but to get the specific game instance that we created. So it's specifically getting the survival game instance. Okay, connect the execution pin, and then pull a wire from the as survival game instance pin and type survival save game. Connect the execution pin, and then connect the input to the save game object we just created. Okay, now we need to actually load the game. So let's create a new function for this. We'll call it load game. Now, first we want to check to see if there is a save game that even exists. So we'll right-click and type does save game exist. Now the username here can stay at 0, but we are going to need to create a slot name. We're going to be using this slot name a lot, and I don't want to just keep having to try to remember what it's called. So let's just create a variable to hold it. We call it slot name, and we'll change its type to string. Compile the widget, and then go down to the details panel, and we'll change the default value. I'm just going to call it survival save game. Okay, now I can drag the new variable right on top of the slot name, and this will attach it to the new variable. We also want to be able to access this slot name in the main level. So let's make a variable in the third person character to keep track of it. So let's go back to our content browser and we'll open up the third person character. Let's add a new variable and call it slot name and make it a string. And then we'll also click on the visibility so that we can access it outside of the third person character blueprint. Okay, now let's go back to the settings menu and let's find the event construct node. That's in the main event graph. At the beginning here, I'm going to get actor of class, and I'm going to set the class to be the BP third person character blueprint. And then we'll grab the slot name variable from the third person character, and we're going to set it. Connect the execution, and then get the slot name variable in the settings menu over here, and assign it to the slot name from the third person character. Great! Now we can reuse the slot name in the main level. Now let's go back to the load game function where we were before. Okay, let's pull out a wire from the return value and type branch. Now on the false execution, we want it to save the game to the slot if it doesn't exist. So first we want to get the game instance and cast it to our survival game instance. Again, this is going to tell it that it's not just any game instance, it's specifically our survival game instance. This allows us to access all the variables. Then we want to get the survival save game variable. Next, we want to save the game to slot. Grab our slot name variable and connect it to the slot name, and then connect all the execution pins. So if the save game does exist, then we want to get it and then set the variables for the save game and the game instance from the loaded save game. So let's right click and type load game from slot. We'll connect the execution pin and then drag our slot name variable onto the slot name input. Then pull out a pin and type cast survival save game. So now we're casting to the survival save game. So it's not just any save game, it's our specific survival save game. Okay, let's create one more function just to keep things clean. We're going to call it set game instance variables. We'll add an input to this function and call it save game, and we'll make it a survival save game type. Next, we want to set the game instant variables, so let's get to that function. First, we want to get all the variables from the save game input of the function. So we want to get the character name, we want to get the difficulty, the invert X, the invert Y, the screen size, the gamma, the bloom, and finally the quality. Okay, next we want to get our game instance and cast it to our survival game instance. We'll connect the execution pin, and then we want to set the survival game variable. So we'll connect the save game input to the survival save game set node. From there, we want to set all the variables in the survival game instance. So set the character name, set the difficulty, set the invert X and the invert Y, set the screen size, set the gamma, the bloom, and the quality. Okay, we'll connect all these execution pins together. And then we're going to connect all of these get variables to all of the set variables. So what we're doing here is that we're loading this save game, and then we're going to get all the variables from that loaded game, and we're going to set our game instance and our save game with all those variables. So whatever's been saved is now going to be input at begin play to these new variables. Okay, let's go back to our load game function, and now we need to call the set game instance variables function. So we'll grab it and pull it over, and then we'll connect the execution pin and connect the save game input. Finally, let's connect our load game function to the event construct node. So go back to the regular event graph and pull in the function, and then connect it to the end of the event construct execution. So now when the widget's constructed, it'll load the saved game if it exists. and then set all the variables of the save game and the game instance to the loaded game variables. We want to do one more thing here for now. Although we've set the variables from the save game, our widgets will not reflect those changes. So we need to also change the values of all of our widgets to reflect these new changes that have been loaded. That way our checkboxes will be checked, our player name will populate with the character name, and it will show the correct selected items in the drop-down menus. So let's create another new function and we'll call it setSaveGameWidgetValues. Let's grab our game instance and cast it to our survival game instance. Connect the execution pin and then pull out a wire and type sequence. Again, this node is going to help keep everything orderly so it can be read more easily, and it'll execute every pin in order. Now, we want to get all of our various widgets, so let's go to the designer mode and click on our character name editable text block. And then we'll go back to the graph editor and you can see that now it's selected in the variables menu. We'll drag it into the graph and get it. We'll do the same for the difficulty dropdown. Then the invert Y checkbox. The invert X checkbox. The screen size dropdown. The gamma slider. The bloom checkbox. And the quality dropdown. Okay, now that we have these, we need 8 total execution pins from the sequence node. So let's add enough pins for that. The last one should actually say 7 because the execution pin starts with 0. All right, now we can change the values. So let's get the character name variable from the survival game instance. Next, let's set the text of the character name text box. We can hook up the execution pin to the first sequence pin. Then connect the character name variable to the in text, and it'll automatically convert it to a text. Okay, next let's grab the difficulty variable. This time we want to set the selected option of the difficulty dropdown. Connect the execution pin to the next in the sequence node, and then connect the difficulty variable to the option input. Okay, next get the invert Y variable. From the invert Y dropdown, set the checked state. Then duplicate the set checked state node. Connect the target pin to the invert Y dropdown. Now we need a branch node. Connect it to the next in line of the sequence node, and then connect to the true and false to each of the set checked state nodes. The top in checked state should be set to checked, and then leave the bottom one set to unchecked. Now if invert Y is set to true, the checkbox will be checked. If it's false, it will be unchecked. Okay, let's duplicate these 3 nodes, and then we'll hook up the invert X dropdown to the target of each. Get the invert X variable and connect it to the branch. And then connect the branch to the next sequence output. Next up is the screen size variable. Pull a wire from the screen size dropdown and set the selected option. Hook up the screen size variable, then hook up the execution pin. Hook it into the next sequence pin. Okay, get the gamma variable. From the gamma slider, set the value of it. Then hook up the execution pin and the gamma variable. We'll hook it into the next sequence pin. Get the bloom variable. Okay, we can copy the 3 nodes from the invert X area. We'll drag them down and connect the bloom variable to the condition of the branch, and the bloom checkbox to the target of the set checked state node. Connect it to the next sequence pin. And then finally we'll go get the quality variable. Pull off a pin from the quality dropdown and set the selected option. Hook up the variable in the execution pin and connect it to the last sequence pin. Now let's go back to the load game function and we'll add this new set save game widget values function to the end of the execution. Okay, that's done for now. So we'll need to do a couple of other things later, but for now we'll move on. Let's go back to the designer mode and we'll start creating the logic of our events. Let's click on the editable text box of the character name menu and then scroll down to the bottom of the details panel. We'll click on the plus button next to the on text changed, and that creates that event. So first we want to hook this text up to our game instance. So we'll right click and type game instance and choose to get game instance. Next we'll pull out a wire and type cast survival and then choose cast to survival game instance. We can hook up the execution pin and then pull a wire from the game instance and type set character name. Again, hook up the execution pin and then drag a pin from the on text change text to the character name value. Again, it automatically converts it to a string. And now we have our player's information going to the game instance. Okay, we also want to save the game with this information. So we're going to pull off a wire from as survival game instance again and type survival save game. And we want to get this variable. Then we're going to pull off from the save game node and type set character name. We'll connect the execution pin and then connect the previous variable to the value of this variable. So finally we want to actually save the game. So pull off another wire from the survival save game node and type save game to slot. We'll connect the execution pin and then keep the user index at 0. But we'll drag in the slot name variable on top of the slot name for the save game. Okay, now we're done with character name logic, so we'll set up the difficulty next. We'll go back to the designer mode and click on the difficulty drop down. Then scroll down to the bottom of the details panel and click the plus button next to on selection changed. So we're basically going to do the same thing here. So we want to get the game instance, cast it to a survival game instance, and then connect it up. And now we want to set the difficulty variable, connect the selected item output to the value, get the survival save game again, and set the difficulty variable of that, and then save the game to the slot, and bring in our slot name variable. Okay, done with difficulty. Invert X and Y are going to be very similar to each other. We'll do them both at the same time. For each checkbox, add the on check state changed event. Similar to before, we want to add each to the game instance and the save game. You've done it twice now, so let's just do it again. Okay, with that done, we can move on to the screen size. And this one's going to be the same as the difficulty, so we'll do the same thing once more. Next is gamma. So click on the slider and scroll to the bottom of the details panel. Click the plus button next to on value changed. This will fire every time the slider is changed. So we'll start by saving this to the game instance in the save game, same as before. So once that is done, we actually want to do one more thing. We want to change the gamma on the camera itself. So first we need to get the camera from the level. We're going to right click and type get actor of class. And we're going to set the actor class to Cine Camera Actor. Let's pull in the camera variable and pull out a wire. Type in get Cine Camera component. Next, let's pull out a wire from that and get the post-process settings. And then pull another wire out from that and type set members. And we want to set the members in the post-process settings. So if we click on this node and go to the details panel, you can see that we can scroll down and change all the different variables. So we're going to scroll down to the color grading global and tick the gamma pin. This is going to open an input to change the color grading global gamma setting. So now we need to change the gamma based on the slider value. Pull off a wire from the gamma node and type make vector 4. We're going to input value, but we want to control the minimum and maximum. So pull off a wire from the intensity input and create a lerp node. We actually want this pin to go into the alpha, so let's disconnect it and connect it to the alpha instead. Then we want to set the min and max. So we'll say the min is 0.5 and the max is 1.5. Then we'll connect the lerp node into all 4 of the make vector 4 inputs. Make sure that all the execution pins are connected. And we're done with the gamma slider. Next up is bloom. So let's scroll down to the bottom of the details and add the on check state changed button. As with the others, we want to get the game instance and set the bloom variable. And then set the save game variable and save the game to the slot. Next, we want to get actor of class and get this in a camera actor, just like before. And then we want to hook up a branch. And then the condition will be from the is checked state of the checkbox. Next, we'll pull out a wire from the Cinecamera actor and get Cinecamera component. And then from that, get the post-process settings. Again, we're going to set members in post-process settings. This time, instead of the gamma, we're going to scroll down to the lens bloom section and then tick the intensity section. Now duplicate the set members in post-process settings and then hook up the struct ref input to the get post-process settings node. Connect one of these nodes to the true branch and the other to the false branch. The true intensity should be set to 0.2 and the false intensity should be set to 0. Okay, one more setting left, quality. So let's scroll down to the bottom of the details panel and add the on selection changed event. Once more, we want to set the game instance and the save game variables and then save the game to the slot. Now pull off a wire from the selected item of the event and type in switch on string. What this node lets us do is to choose an execution path based on a string input. So click on the switch node and go to the details panel. We're going to add a pin for each of the quality options. We have 4 options, so let's make 4 pins. Now this is important. We want to set these values to the exact string values that we have for our quality dropdown. And the best way to make sure there's no typos is just to copy the values that we're using and then paste them into these values. So let's go back to our settings menu designer mode and click on the quality drop-down menu. Let's select the first default option and Control-C to copy it. And then go back to the switch on string and Control-V paste the value into the first pinned index. Now we know that it's the same value. Next we'll do the same thing for the other 3 options. Okay, once that's done, we can also untick has default pin option. We won't need that. Now what we want to do is set the scalability options. So we're going to right click and get the player controller and then pull off a wire and type execute console command. This will let us execute a particular console command directly into the editor. So in the command section, we want to type scalability 0. Make sure there's a space in between. Now duplicate the execute console command 3 times and then hook each of them up to the player controller. We'll connect each of these nodes to the execution pin of the switch nodes. And then we want to change the scalability number for each of the settings. Low should be set to 0, medium should be set to 1, high should be set to 2, and epic should be set to 3. Okay, make sure that all the execution pins are hooked up. Okay, so something that I've just realized is that we're going to have to execute all these sections we just created in the load game, but we don't have a way to do that unless we want to duplicate all of these nodes into the load game function. Okay, I don't want to do that though because it's going to be really inefficient. So instead, let's turn what we did here into separate functions. So let's start with the quality nodes we just created. Let's select everything from the switch on string over. And now there's a great trick when you've already created all these nodes that you now want to be a part of a function. What we can do is we can right click on one of these nodes and then select collapse to function. Now that whole bit of code is a function that we can reuse. Let's give the function a name. I'm going to call it setQuality. Okay, now we can do the same thing for Bloom and Gamma. For Bloom, select the get actor of class all the way over. Right click and collapse to function. And I'll call this one setBloom. And then we'll do the Gamma. So select from get actor of class over, right click, collapse to function. And I'll call it setGamma. Perfect. Okay, now we need to add these new functions to the load game function so that it changes when we load the saved game. So open up the load game function and get the game instance and cast it to our survival game instance. Connect the execution pins to the end here. Now to get the variables, we can just get the variables from the game instance because we just set them from the save game. So get the Gamma, the Bloom, and the quality. Next, let's pull in our setQuality, setBloom, and setGamma functions. Connect the execution pins and then connect the game instance variables to the inputs. Okay, so there's an error we're seeing here when we press play. It says that it accessed none when trying to read the property for the survival save game. And we can actually track this error at the end here. So in the settings menu, in the event graph, it's the node setCharacterName that's having the problem. And if we click on this, it'll take us right to the error. And we can see that it is this character name set variable node here that's pulling the error. Let's scroll over a little bit and see what's causing it. Okay, so it's on the onTextChanged event of the character name editable text. So it must fire this event at event construct. If we go up to the event construct node, we can see that we're creating the save game object and assigning it to the game instance, but it must be firing the onTextChanged before the save game variable can be assigned, so it doesn't exist yet. So let's do this. Go back down to the set variable and right click and type isValid. Scroll down and find the one with the question mark and add it. Make a little space here and connect the isValid between the two setCharacterName nodes. Hook up the survival save game to the input, and that should do the trick. So now when this event fires on construct, it will check if the save game is valid, and if it's not, it will not continue the execution. Okay, now we're going to work on the main level. So let's go to our content browser, maps, and double click on the M main level 01 map. Once it's open, you'll see that it contains a nice big level to play around with. This is a part of the shooter example project provided by Epic Games on the Marketplace. I would highly suggest downloading this whole project and digging through it because it's a great example of how to set up a first-person shooter with multiplayer, and the best part is it's free. Thanks, Epic. So first we're going to build the HUD for gameplay, and this is going to be everything that our player sees during play in the main level. We'll work on the slider bar widget first, so go to Survival Game UI and double click the slider bar widget. This widget is going to act as our on-screen UI for the battery, oil, and wrench indicators. Let's search for a canvas panel and we'll drag it onto our hierarchy. Then we'll search for a progress bar and drag it onto the canvas panel. We'll rename it to Progress Bar Main. Click on the progress bar and in the details panel, click on anchors. We'll shift-control-click, fill top to bottom, right aligned anchor. This will fill the space from top to bottom, but allow us to input a size value for right to left. Change the size to 250 and the offset top and bottom to 5. Under progress, change the bar fill type to right to left. Now open up the style section. I want the background image to have an opacity of 0.5, so let's change the tint alpha for that. Alright, next let's search for text and we'll drag one onto the canvas and rename it to Text Main. Click on the new text and click on the anchor setting. Shift-Control-Click on the centered right align setting. Change the position X to -275, and then finally set the font size to 18. Next, we need to go to the graph editor mode and create a new variable. We'll call it color, and we'll also need to click on the little closed eye next to it. You'll see that the eye changes to open. And again, this is going to allow us to manipulate the variable from outside of the current widget. Next, we'll change the variable type to linear color. Okay, drag the progress bar to the event graph and get it. Then we'll pull a wire off the progress bar and we'll search for fill, color, and opacity. We want to set this variable. Connect the execute pin from the event pre-construct to the set. Now drag the color variable to the event graph and get it. Connect it to the fill, color, and opacity node. Now if we go back to the designer mode, we can change the value on the progress bar and see that it's inheriting the color variable's color. Go back to the graph editor mode. Next we want to create another variable and call it text. Again, click the eye so that it will be visible outside of the widget, and then change the variable to a string. Now go back to the designer mode and click on the text element we created. Go to the content section and click on the bind drop-down menu next to the text value. Choose our new text variable. Now the text will be bound to the value of this variable. Okay, let's make one more variable and we'll name it value, and let's change the type to float. Again, open the closed eye so that it's visible, then compile, and then under details we'll set the default value to 1. We're going to bind this value to the percent property. So let's go to the designer mode and click on our progress bar. Under progress, next to percent, select the bind drop-down menu and choose our new variable value. Okay, we're done with the slider bar for now. So next let's tackle the actual survival menu. Go back to the content browser and go to Survival Game UI and double click on the Survival Menu widget. First search for a canvas panel and drop it into the hierarchy. Next search for slider bar and we'll drag our custom widget under the canvas. We'll rename it to wrench bar. So select the slider bar widget and then we'll use the bottom right anchor point so that it appears on the bottom right of the menu. We can set the position X and position Y to -25 and then set the size to 100 by 25. Now if you look under the default section of this widget, you can see that we have 3 variables that can be set: our color variable, text variable, and value variable. These are the 3 different variables that we set up in the slider bar widget, and they're visible because we click that closed eye to make them visible outside of the widget. So we'll ignore the value variable for now, but we'll set the text and color in the survival menu widget. I'm going to set the color to kind of a light beige and the text to repair. Don't worry if the text doesn't change in the widget menu, it will change at runtime. Now let's duplicate our slider bar twice. We'll rename the first one to battery bar and the other to oil bar. Change the battery bar position X to -25 and position Y to -65. We can change the color to a different color other than the wrench bar. I'm going to choose a yellow color, and then change the text to battery. Now let's set up the oil bar. Select it and change its position X to -25 and position Y to -105. Change the color to a different color other than the battery and wrench. I chose a dark brown. And then set the text to oil. Next, let's compile the widget and test it out. If we press play in the editor, we should see 3 different bars at the bottom right. The top should say oil, the middle should say battery, and the bottom should say repair. And now that I'm looking at it, I don't think that I want text. I think I want to use an icon instead, so let's change that. Let's go back to the slider bar widget and then go to the designer mode. I'm going to delete the text element. And then instead what I want is an image. So I'm going to search for one of those and drag it into the canvas panel. I'll rename it to image main and then set the anchor to fill the top to bottom and right alignment. Next I'll change the position X to -275 and the size X to 25 because that's the size of the widget in the survival menu widget. Now we want to go back to the graph and create another variable. We're going to call it image. Make it visible. And we're going to make it a texture type. I want to bind this variable to the image of this new element, but if we go back to the designer mode and click on the image, we can scroll down and see that there's no option to bind on the image. However, if you look up here, you can see that there's a place to bind a variable to the whole brush, so let's do that instead. Go back to the graph editor and we'll change the variable type to a slate brush. And now let's bind it to the brush variable. I also want to bind the color variable to the image thumbnail as well. So go down to the color and opacity and bind it to color variable. Next, we can go back to the survival menu widget and assign some icons. First, we'll click on the wrench bar and open the image variable. I've included a few icons in this project that you can use as icons, but feel free to use your own. Change the image to the icon wrench texture. We'll do the same for the battery and oil bars. Again, it won't necessarily show up in the widget here, but if we go back to the editor and press play, we can see that they do show up. Okay, I like this a lot better than the simple text, but I don't really love the colors. I think I just want to keep them a simple white. So I'm going to go change that really quick. Okay, that looks better. I think I'm just going to keep that. And I hope that you can see the power of using user-created widgets. Okay, so for now, our battery and oil are static. They don't move, but we want them to slowly tick down as your robot gets hungry and thirsty, so let's do that now. Go back to the survival menu widget and go to the graph editor. We're going to use the tick event to tick down the battery and oil over time until it reaches 0. So pull in the battery bar to the graph editor and then pull a wire and type value. Choose set value and connect it to the execution pin of event tick. Next, pull another wire from the battery bar and get the value. Pull a wire from the value and type the minus key. Choose subtract. Hook up the delta time from the event tick to the other pin of the subtract node. And then finally connect the subtract node to the set value node. Now let's see what happens. Let's click compile and go back to the editor. When we press play in the editor, we can see that the battery progress bar is now ticking down. But man, is it fast. We don't want our battery charge to run out quite as fast as that. Let's go back to the survival menu widget. Okay, so if we want to make it slower, all we have to do is just add a divide node between the delta time and the subtract node. So we'll type a / to search for a divide node. Let's try a value of 20 and we'll see what happens. There we go, that's more like it. Now the bar's ticking down at a much slower pace. Now we can do the same thing for the oil slider bar. Pull in the oil bar. You should know now how to set this up. In fact, we can just duplicate everything except for the battery bar and reuse it. Make sure to connect all the pins, then compile and go back to the editor. Now when we press play, we can see that both bars are moving down slowly. Okay, we're going to hook up the wrench bar a little bit differently. We don't want to have it drain over time. We only want to change it if the character gets hit. So next we're going to create a function, and we're going to call it take damage. Click on the function and create a new input and call it damage and make it a float variable. Now get the wrench bar and drag it into the editor window. Pull out from the pin and type value. We want to get it, and then we want to set it. So create both nodes. Next, we want to pull out a pin from the get node and subtract. Connect the damage input to the other side of the subtract node, and then connect the subtract node to the set node. Then connect the execution pin. Okay, let's compile. Now we're going to add 3 more functions to this widget. Each one is going to add battery, oil, and wrench. So let's create those. The first one we'll call add battery, the second one add oil, and the third one add wrench. Each of these is going to need a float input, so we can add a float to each of the functions. Okay, now in the add battery function, we're going to pull in the battery bar variable. From there, we're going to pull off a pin and create both a get and a set value node. Now here we're going to add to the value instead of subtract, so pull off from the get node and type a plus symbol in the search bar. We'll connect the input pin to the other side of the add node, and then connect the add node to the set node. Finally, we'll connect the execution pin. Now the problem is that technically we could increase the value beyond 1, and we don't want that. That would be cheating. So let's set up one more thing. We're going to add a branch node after the set node. Then pull out the output pin from the set node and type a greater than symbol. Type 1 in the second area here and connect it to the branch. So what this is doing is saying that if the value is greater than 1, we want to do something. And what we want to do is to set the value back to 1. Okay, now we can do the same thing with the other functions. So first let's just grab all of these nodes and we'll copy them. Then we'll double click on the add oil function and we'll paste all those nodes into this function. First off, connect the execution pin and the input value. Then we want to replace the battery bar with the oil bar, and we're going to connect it into all the different places that the battery bar was connected. Once that's done, we can delete the battery bar node. Okay, now we're going to do the same thing with the add wrench function. Let's paste all of our nodes again, and then connect the execution and the input. Then we'll add the wrench bar, and then connect the wrench bar where the battery bar is connected. Once that's done, we can delete the battery bar again. Okay, so there's one more thing we want to do with our survival menu. Let's go back to the main event graph. We want to add an end game if you lose. So grab the battery bar, the wrench bar, and the oil bar. And we want to get the value of each of these. Then we want to add a less than or equal to node to each one. And we want to keep the second number as 0. Next, pull off from the less than or equal to node and add an OR node. We'll add one extra pin to the OR pin, and then we'll connect each of these pins to the less than and equal to nodes. From there, we'll pull off from the OR pin and add a branch node. And then we'll connect the execution pin. Okay, from here we want to create the end game widget, pause the game, then destroy this widget. So we'll right click and type create widget, connect the execution pin, and choose the end game widget as the class. Connect the owning player to the player controller, and then add the widget to the viewport. Next, we want to pause the game so you can't move your character around anymore. We can add a node called Set Game Paused and tick the paused option. We also want to show the mouse cursor so a player can pick between buttons. So get the player controller, then pull a wire from that and type Set Show Mouse Cursor. And we want to set it. Now it'll show the mouse cursor whenever the game ends. And then finally, we want to destroy this widget so that it doesn't keep animating. So to do this, add a remove from parent node and keep the target as self. You may remember that we never connected the settings button in the start menu. Well, we're going to do that now. So I want to do something cool with this. We have our start menu kind of lined up with the character in a nice composition. And what I want to happen is for the camera to shift to the left so that when the settings menu pops up, it comes in from the other side and lines up opposite of the start menu. So that way we have a nice little animation that makes the menu more dynamic. Let's open up the start menu widget again. First off, let's add our settings menu to this widget. Search for it in the palettes panel and drag it into the hierarchy under the canvas panel. And then set the anchor in position to fill all. Next, let's open up the animations panel. We want to create two animations. One's going to be for the settings menu and one's for the main menu. So let's create them. Call the first one settings menu anim and the second one main menu anim. Now let's click on the settings menu widget and scroll down to the render transform area. We're going to animate the translation X value. First, let's start the settings menu off screen, so set the value to -1200. And now let's click on the settings menu anim and add a new track. Choose the settings menu on the top here, then add a new track to the settings menu and choose transform. Open up the transform section, and then the translation section. Make sure that the time slider is at frame 0 and add a keyframe. The value should be -1200. We want this to be a quick animation, so go to frame 0.5 and set the translation X value to 0 and add another keyframe. Now we can scroll back and forth and see the menu pop in and out of the screen. Next, let's do the transition for the main menu. Click on the top level grid panel in the hierarchy, then click on the main menu anim and add a new track. Choose the grid panel at the top. Add a new track in the grid panel and choose Transform. Open up the Translation tab and add a keyframe to the Translation X track. Once again, move this time slider to 0.5 and set the Translation X value to 1200. Add another keyframe and scroll to see the animation. Now let's execute the animations. So go to the Settings button and scroll to the bottom of the Details panel and add the OnClicked event. Now go over to the Variables menu and drop down to see the Animations section. We need both animations, so let's get them both. Pull a wire from the Settings menu anim and type Play Animation Forward and connect the execution pin. Then pull out a wire from the main menu anim and type Play Animation Forward. Now we also want to hook up the On Hovered and On Unhovered to match the other buttons. So create a new variable and call it Settings Text Color. Change the type to linear color. Compile and set the default color to white. Then go back to the designer mode. Bind the new variable to the Settings Text Color and Opacity. Go back to the Settings button and add an On Hovered and On Unhovered event. Pull in the Settings Text Color variable and set it. Then duplicate it and connect each to the two events. The On Hovered color will be our blue color, and the On Unhovered will be white. Okay, let's add a new function and we'll call it Settings to Start Menu. Make sure it's open and then pull in both of our animations. This time our main menu anim and settings menu anim are going to play in reverse. And then we'll compile the blueprint and go to the settings menu widget. So we didn't add a back button, so let's go ahead and do that now. Go to the designer mode and get a canvas panel and add it under the main canvas panel. Rename it to Back Group and set its anchor and position to middle right. Set the position Y to 400 and the size to 250 by 40. Next, drag a button on top of the canvas panel and rename it to Back Button. Set the anchor and position to Fill All. We want this button to look like the buttons on the Start menu widget. So go to Appearance Style and set the normal, hovered, pressed, and disabled draw as none. Okay, now add a text block to the back group, above the back button. Rename it to Back Text and set the text to Back. Set the anchor and position to right center and tick Size to Content. Set the position X to -5. We'll set the font family to Arial font and the size to 18. Now click on the back button and scroll to the bottom of the details panel. Add an on clicked, an on hovered, and an on unhovered event. Next, we'll create a new variable and call it back text color, and we'll change its type to linear color. Compile the widget and we'll set the default value of that variable to white. Now we can drag it into the graph and set it. Duplicate it one time and then connect the execution pin of each to the on hovered and on unhovered events. We'll set the hovered color to our blue color and on unhovered to white. Go back to the designer mode and click on the back text. Bind this new variable to the color and opacity value. Okay, next we need to animate back to the start menu. So go back to the graph editor and right click next to the on clicked event for the back button. We have a reference of our start menu on our third person character. However, we've overridden the pawn in this level to be the default pawn. But we can still get the third person character in the scene. So we can get actor of class and change the class type to third person character. From there, get the start menu from the third person character, and then call the function settings to start menu. This will play our animations in reverse. Okay, let's compile it and test it out. So now you can see that when we press the settings button, the menus shift over, and when we click the back button, it shifts back. If you notice, the settings menu blocks the character when it comes on screen. So we want to have the camera change the position with the menu. So go back to the third person character blueprint. Now the first thing we need to do is to get the camera that's in the scene. We only need to do this bit when we're in the entry level, so let's right click and get an actor of class up here, where we branch off based on the level. Connect the execution pin to the top part and change the class type to Cine Camera Actor. We'll promote that to a variable and call it camera. Now let's right click and create a new custom event. Call it Move Camera Event. Pull off a pin and type multigate. A multigate will execute a series of pins in order similar to a sequence, but it only moves to the next pin each time the function is called. Tick the loop checkbox so that it repeats. Now we need to right click and create a new timeline. Name it Move Camera and then double click on it. Let's add a float track and set the length to 0.5. Right click in the graph and add a keyframe. Set the time and value both to 0. Then right click and add another keyframe. This time set the time to 0.5 and the value to 1. Click and drag around both of the keyframes and right click on one of them, and then choose Auto. This is going to smooth the keyframes and make them look a lot nicer. Now go back to the graph editor and hook up the 0 output of the multigate to the play input of the timeline. Then hook up the 1 output of the multigate to the reverse input of the timeline. Pull a wire from the Move Camera output and get a lerp node. Move the connected pin from the A side of the lerp to the alpha. We want the A side of the lerp to be 210 and the B side to be minus 210. Now let's bring in our camera variable and pull out a pin and get actor location. Right click on the return value and split the struct pin. Next, pull out another wire from the camera and set the actor location. Connect the execution pin to the update output of the timeline and right click on the new position and split the struct pin. Now we want to connect the X and Z of the get location to the X and Z of the set location. Then we want to connect the lerp to the Y position. Okay, now let's add one more lerp and we'll connect the alpha to the Move Camera output and make the A side minus 10 and the B side 10. Pull another pin from the camera and type Set Actor Rotation. Split the struct pin and connect the execution pin. Connect the lerp to New Rotation Z. Now compile the blueprint and head over to the Start menu. Scroll down to the Settings button on clicked event. Right click and get Actor of Class. Then connect the execution pin and change the class to third person character. Now pull out a wire from that and type Move Camera Event. Next, copy these two nodes and go to the Settings to Start menu function. Paste the nodes and connect them. Alright, compile and let's test it out. Sweet, now the camera's moving with the widgets. And guess what? We're done with our entry level, so well done. So we want to keep track of our score through the level. We can tick up a value as time moves through the game and then display the final time when the game ends. Okay, open up the current score menu. Let's add a canvas panel to the hierarchy. Next, we'll add an image under the canvas and rename it to Image BG. This will be the background. Set the anchor in position to fill all and change the opacity to 0.2. Finally, add a text block and name it to text main. Tick the is variable checkbox because we'll want to assign this text at runtime. Set the anchor in position to center right and change the position X to -5. Then tick the size to content box. We'll change the font family to Arial font and the size to 18, and then we'll also change the color to our blue color. Now let's go to the graph editor and add a new variable. We can just call it text. Make it visible and change the type to string. Compile and go back to the designer mode when you're done. We'll bind this new variable to the text property, and then we'll compile and save and head back over to the survival menu. Search for the current score widget and drag it into the current menu. Set the anchor in position to top right, and then set the position to -25 and 25, and change the size to 250 and 50. Go to the graph editor and let's add a new variable and call it score. We'll make it a float variable. Then make a little room here in the event tick and drag the score variable in and get it. Then drag it in again and set it. And we'll connect the execution pins here. Create an add node from the get score node, and then connect the delta time to the other side of the add node, and then connect the add node output to the set score. Now pull in the current score widget and get it. Then get the text main component. From that, set the text variable and connect the execute pins. Connect the score output to the set text node. It'll automatically convert it to a string. Compile and let's see what it looks like. Okay, that's interesting. Not really what I was hoping for, because the decimal points keep changing. It makes the text jump around all over the place. Also, there's nothing that says it's the current score. Let's right-click and type append and choose append under string. This is going to allow us to add a title to the string. On the A input, type current score : and make sure there's a space after the colon. We also want to shave off some of the decimal points for the score. We'll just say that we only want 1 decimal point, but how do we do that? Well, let's use this technique that works pretty well. First, let's multiply the score by 10. This is going to move the decimal point over to the right. Then we'll round it to an even integer, and this is going to cut off all decimal points. Then we'll convert it back to a float, and then finally let's divide it by 10 so that we get the correct decimal point again. I also want to save this new number as a variable so we can use it later. So let's make a bit more room here and convert it to a variable. We'll just call it simple score. And now let's plug that number into the B side of the append. Finally, plug the append node into the in text of the set text node and compile. Okay, now if we press play, we can see that there's a much better representation of our score, and it also has a title so that we know what it is. The final widget that we need to set up is the end game widget. So let's double click on this widget in the content browser to open it up. First, let's add a canvas panel. Then add another one under the first one and rename it to menu. Set the anchor point in position to center and make the size 600 by 300. We want to tell the player that they lost, so let's add a text element and rename it to header text. Change the anchor in position to top center, and then tick the size to content checkbox. You can change the text to whatever you want the player to see when they lose. I'm just going to put game over. Let's also move the text down 25 pixels and change the font family to World Conflict and set the font size to 60. Now let's add a text to tell them what they died from. We can call it death by text. Tick the is variable box to make it a variable. We can set its anchor and position to top center and tick the size to content box. Then set its position Y to 125, the font family to Arial font, and the size to 18. We also want to let the player know what the current high score is, so let's make another block of text and we'll rename it to high score. Set the anchor and position to top center again, and then set the position Y to 215 and tick the size to content box. Let's make the color of this one our blue color. Then let's change the font family to Arial BD font. This is the bold version, and set the size to 24. We also want to tick the is variable box so that we can change this text later also. And then next we'll add a text to tell the player what their final score was. So let's rename it to final score, and then make the anchor and position top center. Then set the position Y to 165 and tick the size to content box. Now we're going to change this value later, so we can just leave the text blank for now, but we do want to make it a variable so we can access it. Let's change the font family to Arial BD font and change the size to 20. And I'm also going to change this one to our blue color. Next, we want to ask if the player would like to try playing again or if they'd like to go back to the main menu. So let's add another text element and then center the anchor and position again, and then tick size to content, and we'll put this one at 250 on position Y, and change the font size to 18 and the font family to Arial font. And then I'm going to set the text to say, would you like to try again or go to the main menu. Next, let's add a button. We can change the size to 200 by 30 and then set the anchor and position to top center. We'll set the position X to -175 and the position Y to 300. Open up the style section and change the image to plain white. Change the tint color to white and the alpha to 0.2, and then change the draw as to image. Do the same thing for the hovered image, but set the tint alpha to 0.5. And then also do the same thing for pressed, but change the tint alpha to 0.2. Now add a text to the button and name it Try Again Text. I also forgot to rename my button, so let's rename it to Try Again Button. Set the font family to Arial font and the size to 14. And then change the text to Try Again. And I'm going to set this one to our blue color. Now let's duplicate this whole button and we'll rename the new button to Main Menu Button. And rename the text to Main Menu Text. And then we'll set the whole position X to 175 and the position Y to 300. And then we're going to change the font text to Main Menu. Let's also change this canvas size so that it fits all of the text. I'll put it at 350. Next, let's connect the on-click events for the buttons. First, let's do the Try Again button. Let's create the on-clicked event for the button. Now we want the level to start over if the player chooses the Try Again button. We can do this by just opening the level again. So let's type in Open Level. We'll choose the object reference version. And then we'll choose the level. We want to reload the main level, so let's choose M main level 01. Okay, now let's hook up the main menu button. So go back to the designer mode and add an on-clicked event. Then pull off a wire and type Open Level. And then this time we want to choose the M entry 01 level. That'll go back to our main menu. Next, we want to connect the final score setting. So go back to the Survival menu widget, and then make a little room between the Add to Viewport and the Set Game Pause nodes at the end of the event tick. Pull off a wire from the Create In-Game widget and type Final Score. This is our text that will display the final score. Next, pull off a wire from that node and type set text. Connect this node between the add to viewport and the set game pause nodes. We want to create a string that will set the text of this text block. So pull off a wire from the in text pin and type string. Select the toText node. From there, pull off a wire and type append. In the A slot, we want to write final score : and then make sure there's a space after the colon. Next, we want to get our simple score variable and connect it to the B side of the append string node. And again, it automatically converts this to a string. And then we're going to add one more pin to the append node and type seconds. And we're going to make sure there's a space before the word seconds. Next, we're going to get the high score and set the text. So first, let's get the game instance and cast it to our survival game instance. And from that, we're going to get the high score variable from the survival game instance. Next, we'll get the high score text from the end game widget. Okay, so we want to compare the current score to the high score. So let's bring in the score variable, and from there get a greater than node. Connect the high score to the other side of the greater than node, and then create a branch from it. We'll connect the branch to the cast node. So if the new score is higher than the high score, we want to set the new score as the new high score. So grab the high score from the game instance and set it. Then grab the save game from the game instance, and then get the high score from it and set it. Connect these to the true side of the branch, then connect the new score to each of them. And then we want to save the game to the slot. We need to get the player pawn and cast it to the third person character. Then we need to get the slot name from the third person character. Grab the survival save game and pull out a wire to save game to slot. Connect the slot name variable to the slot name input. Finally, we want to set the text. Let's bring the high score text a bit closer here, then pull off a wire and set text. Next, right-click and search for append string and create a node. Add a pin to it and put new high score in the A slot. Make sure to add a space at the end. In slot C, type seconds and make sure you put a space before the word seconds. For the B slot, we want to get our simple score variable and connect it. Then connect the append node to the end text of the set text node. And connect the execution pin. Now we want to do the false side of the branch. Here we still want to display the high score, but we don't want to change it. I want to do the same thing that I did for the simple score here and shave off a few decimal points. So let's grab these nodes and copy them. And then paste them over here. I also want to duplicate the set text, toText, and append string nodes. Copy and paste them, and then connect the execution pins to the false branch. Okay, the A slot for this append should say high score with a space at the end. And the C slot should stay the same. Connect your string of logic here to the B slot and connect the high score from the game instance to the multiply node. Okay, now the high score is done. I also want to change the death by text based on how you died. So make a bit more room here and add a sequence node. We're going to add 2 pins to it and then connect the execution pins to both sides of the branch. Create a branch node and connect it to the first pin. Now let's go back here and grab all these conditions. We don't need the OR node anymore. Paste them over here and connect the battery one to the condition input. Now let's go back to the Create In-Game widget and drag a wire off and type death by text and get it. If you don't see it, make sure that the is variable is set in the in-game widget of that text object. Next, drag a wire off the death by text node and set text. Connect that to the true side of the branch. Now we want to come up with something punny to tell the user if that's how they died. How about, sorry, you ran out of juice. Now let's copy these two nodes and paste them twice. We'll hook up the execution pin to the second and third pin of the sequence node. Hook up the target of the death by text to the in-game widget. Now hook up the wrench bar to the condition in this one, and the oil bar to the condition on this one. We'll change the text for the wrench one to, "You are wrenched from this world." And the last one will change the text to, "Time for an oil change." And let's compile. Okay, it looks like we're getting some errors, so let's go track those down and fix them. So this one I think is because we didn't compile the in-game widget, so it doesn't recognize the variable. Okay, that fixed that one. And this one looks like it's because there isn't a target hooked up to the set text node, so let's hook that up. Recompile, and there's no more errors. Finally, let's hook up this last execution pin to the end of the sequence node. Okay, we're done with this bit now. Let's go back to the in-game widget and do a couple more things to fancy it up. So I'm going to add an image to the second canvas and then put it behind everything else in the hierarchy. Rename it to Image BG. I'll set its anchor and position to fill and set the alpha of the color and opacity to 0.25. And then finally I'm going to create a background blur. I'll pull the element into the first canvas panel and then put it behind the second canvas panel. Set its anchor and position to fill and set its blur strength to 10. Alright, let's test it out. Let's go back to the main editor and click play. We can just wait for the battery and oil to tick down to 0. And make sure that the in-game widget shows up. Sweet, now we can click try again or go back to the main menu. So we're getting an error after we play from the main level. The problem is that the save game doesn't exist when playing from the main level because it's being created in the entry level. However, since we're playing right from the main level, it doesn't ever get created. Let's just do something really quick to solve this issue. Even though we're always going to play from the entry level once we're done creating the game, we are going to be playing from the main level a lot to test things out. Plus, I don't like leaving unresolved errors. So let's go to the survival menu widget. On event construct, let's get the game instance and cast it to the survival game instance. Then let's get the survival save game. Now we want to check if this is valid or not. So pull out a pen and type is valid and choose the one with the question mark. Now if it is valid, we want to do nothing. But if it's not, then we want to create a new save game. So pull off a pen from the is not valid and type create save game object. Choose the survival save game class. Then pull off a pen from the as survival game instance and type survival save game and set it. Connect the newly created save game to the set node. Okay, that should take care of this error. If we try the level again, we can see that the error does not pop up now. You may see a strange thing happen when you go back to the main level. A large sphere shows up and pops the third-person character away from its position. There's an easy fix for this, but we're going to need to make a couple of more blueprints. Go to the Blueprints folder and then create a new blueprint. This time the type's going to be a game mode base. Let's rename it to Entry Game Mode. Now create one more blueprint class of the type Pawn. Rename this one to Entry Pawn. Double-click on the entry game mode and head over to the details panel. Change the default pawn class to our entry pawn that we just made. Compile this and save it, and then open up the entry level. Now we're going to go back up on the top to available blueprints. We're going to open it up and then go down to the bottom where it says World Override. Select the Game Mode base class, and instead let's change it to the Entry Game Mode. So now when we go back to the entry level, we don't have that same problem anymore.